Yeah, I think so. What else?
Good morning, everyone. Thank you for joining our session today. Our next speaker is Dr. Mike Orosz from the University of Southern California. He directs the Decision System Group at USC's Information Sciences Institute, and he's a research associate professor in the Department of Civil and Environmental Engineering. He's got over 30 years of experience in government and commercial software development, systems engineering and acquisition, basic and applied research and development, project management, and has developed and deployed several successful products in both the government and commercial sectors. He also serves as a subject matter expert to the government in the areas of systems engineering and acquisition, intelligence analysis, in particular areas of open source intelligence and cyber exploitation. He'll be here to present his research on WRT 1041, Space and Missiles Center, Production Corps, mission engineering, and integration of emerging technologies. Over to you.
Okay, thank you. And good morning. As was indicated, we're going to talk about the project we've had. This is going on 2 years that we had, and we've had several other projects that we'll talk about briefly here. So agenda, the objectives of our project and the timelines that are involved. Brief overview of some previous results. I want to set some context, and then go into where we're at right now with the current project. And then some, summary of what's next steps. So our project team is again USC Information Sciences Institute. We're in Marina Del Rey, but we've got an office right here in Arlington, right across the Potomac, and then up in Boston. And we've been with the School of Engineering for 50 years now, and we're also teamed with SERC, providing subject matter expertise to us on this project. And our funding agency, it was the Space and Missiles Command, but that changed. It's now the Space Systems Command, and it's not the Air Force anymore. It's the Space Force, and it's not the Production Corps anymore. It's Military Command, Positioning, Navigation, and Timing. So basically, a new service has stood up. And so we're going through that process of trying to figure out what the naming is and who's in charge. But they've been very, very supportive throughout this project. And the pre-performance, we've been at this for a while. Okay, a number of different SERC projects, one sort of following after another, different funding sources, pots of money, but basically the same general areas. So it's kind of a nice for an A/B comparison. We're not apples and oranges. We really are apples to apples, just different programs, but same complexity, same problem space. Our objectives, specifically, we're looking at improving space-based software acquisition. Okay, can we do it faster, better, cheaper? Although it's probably questionable whether it'd be cheaper, but you can definitely do it better. And we're looking at using Agile and DevSecOps and digital engineering technologies and processes to try to make that happen. And what we're doing is we're looking at, what's the current state of art. I say that with quotes because there's a lot of Agile work going on now in the DoD, but still a lot of the programs out there are waterfall based. And we're looking, how can we transition from that environment to an Agile and DevSecOps environment? And at the same time, incorporate new processes, new technologies into this particular space program that we're working on. And how do we educate and train the current and future workforce? Because it's throwing people into a program and they don't know anything about Agile is difficult. Okay, which we've experienced in the projects. And our process is first understand the current acquisition environment. I'm going to have to change this because we actually, I think, have a pretty good idea what the acquisition environment is. We've been in it now for a while. But what we do is we're immersed. We're not CETAs, okay, system engineering technical advisors, but we advise and provide subject matter expertise to the CETAs and to the government and to the contractor. They don't have to take our advice. We're just making recommendations, but we are embedded. We're at all the scrums, all the ceremonies, all the working group meetings. We are involved in systems engineering. So we're in the trenches where we see what's working and what's not working. And that allows us to get a wealth of data collected over the last coming up on 6 years. Okay. And again, we take that and develop basically a cookbook, if you will, or a roadmap on how to transition from waterfall to agile and DevSecOps, and including workforce training. And then our ultimate goal is to generalize this, so it's not just space; it's all the DoD and really any large enterprise where you have many working parts and many vendors all working on different parts of an overall enterprise. How do we do that? How do we work in that environment? So this project, again, it's been multiple projects, and there are really 4 programs I want to talk about. The first 3 are going to be quick because we've already talked about them before, but to again set time to context. And then the last one we'll spend the rest of the discussion on. Project A was all waterfall. Okay, mid-size program, about 180,000 lines of code. We call that our baseline. It's just the traditional DoD 5000.02 approach that's been around forever. The second project, Project B, same. This is all command and control. It's the ground segment of the space programs, command and control. Same complexity, a little smaller in size, but same. It's the same program basically. But in this case, there were 2 thrusts. One was all waterfall, and in parallel to that was another thrust that was all done in Agile and DevSecOps. Roughly the same number of lines of code, same complexity, both sides. So you had like a 50-50 split. Then the third project, really there was no code. It was just a study to transition into the final project. But this was used to look at modernizing these existing software factory, and as well as to help both the contractor and the government ramp up on Agile technology. Okay, so haven't really started the project yet, but they had some funds to go ahead and do a study to try to get us ramped up, and also to initially populate the project backlog. And in Project D, which is currently in progress, it's going to be about 180,000 lines of code probably by the time we're all done, and we're a third into it, and we're already learning some things. So again, projects A and B have been presented before, but again, I want to set context. And this is an example of benefits of Agile and continuous integration. Even in a DoD space program, there's definitely benefits. In this chart, there are 3 traces, but the blue one is just a delta. You can ignore that one. The top trace, which is green in color, that's your Project A. Okay, and these are bugs, basically, problem reports that are discovered during integration and testing. And traditional, and you see in a waterfall, you see peaks, bow waves of problems being discovered as you, particularly towards the end of a program, where you sort of pile up all your integration and testing towards the end. Very traditional waterfall. There's 2 peaks here because there were so many PRs, problem reports generated, that they had to stop integration and testing and address those PRs and then start up again. And we got another bow wave. Okay. The lower trace, which is yellow or golden color, is Project B. That's the one that was 50% waterfall, 50% Agile. And you can see, accounting for the size, there's differences in the size, software lines of code, there was definitely a big difference. Okay. They came in with only, they still had a peak, a bow wave of PRs, but much less than the traditional waterfall. So already we see some evidence that, Agile and DevSecOps, granted it's just one program, but it appears that there's evidence in support of, let's go with the Agile waterfall approach. Let's tease Project B apart a little more. And this is the hybrid program. Half of the program is waterfall, the other half is Agile. The upper trace, again, we're just tracking bugs here, PRs that are discovered during integration and testing. That upper trace is the waterfall part of the program. Down at the very bottom, sort of in bluish green, you can barely see it, is the problem reports detected for the integration and testing of the Agile portion of the program. Notice the drastic difference. There's very little PRs, they're going to have them, but very few. And the reason for that is because they were testing, integration testing from day one all the way to the end. And whenever a problem presented itself, they addressed it then and there. They put it into the project backlog, they put a priority on it, and they started working it as soon as possible. They didn't wait and let it cascade and cause other problems to develop. Not only is this interesting from the perspective that the Agile part is, at least from tracking bugs, is much more efficient and it appears cheaper. But the team that did the Agile part of this program started 10 months after the waterfall team started. Again, same number of lines of code for both sides. And the team that did the Agile were newly recruited out of college. They had never really worked on an Agile program. They didn't even know what a DoD acquisition program was. They were very green. Now the product owner is very seasoned and knew Agile and DevSecOps processes, and that greatly helped. But nonetheless, inexperienced team starting 10 months later and still had a remarkable return in terms of reducing the number of bugs, number of problem reports that were generated during integration and testing. So again, just to set context, what we've done in the past. And in the study, again, I won't spend time on that because it was just a transition to really ramp up the team for Project D. Project D, it's also a hybrid project. It's about 70% Agile and 30% traditional waterfall. And that 30%, it may even be 20%. We'll see at the end of the day. It's really the programmatic stuff. It's IMS, integrated master schedule tracking, EVM metrics, the stuff that's been around for 70, 80 years that the government and the contracting environment, they're comfortable with those metrics. Well, we need to work in that environment. So we have to, deal with siege rules, et cetera. But for the most part, all of the development is Agile and DevSecOps. And again, 52 months in duration is what we're looking at. And our Agile implementation, we're using a modified version of the SAFe framework. So we don't have epics and a lot of what's typically found in a SAFe environment, but we do have program increments. In this case, they're 13 weeks long. And we do have an ART team. That's an Agile release train. It sort of provides the management over multiple teams to ensure that there's collaboration, et cetera. Each of those program increments, there are 4 3-week sprints. And then there's a 1 week, what we call a pit stop at the end, which is where you do some training and some demonstrations, reflection, exploration, if you will, on something that's novel or different or new as you want to look at it, and sometimes catch up. So some of our teams will use that extra week to catch up if they didn't get everything done, which is becoming a problem now. But we'll see how that goes. And we have 6 Scrum sprint teams. 4 are mission related. So they're actually developing the code that is the command and control system. And then 2 of them are enablers. One is systems engineering, and the other one is the software factory team. Okay, have to have them, but they're typically not part of the requirements that the government says, thou shalt deliver us a command and control system. They don't always include also a software factory. And don't forget systems engineering, but you got to have them. Now, I will note that starting with the most recent program increment, which we call program increment 5, one of those enabler teams was split into 3 teams, and I'll get into that in a minute. But for all the data I'm about to present, we're going to look at it to 6, not 8, but 6, so that we're comparing apples to apples. All right, so early results. So the first 17 months, a lot was focused on, some more system engineering to, extend what we did in the study, which is Project C. And we started doing some coding. All right. And the performance metrics that we were tracking, still too early with integration and testing. So we don't have good results yet for problem reports. That'll probably be in another 6 months. We'll start to have some good data there. But we are tracking how many features and stories that are getting done every sprint and every PI. And so again, just a reminder, requirements, which support a capability, those decompose into features. And a feature is typically worked within a program increment, that 13-week interval increment that we talked about. And then each feature is decomposed into a number of stories. Stories are typically worked within that 3-week sprint. And generally what it's frowned upon in the agile world, as many of you know, is if a feature spills over a PI boundary, in other words, you can't get it done in that 13 weeks. That's sort of, it can happen, but you don't want to see that happening a lot. It means they're probably not sizing their features correctly. And if you see a story going over a sprint boundary, a 3-week interval, it can happen, but you don't want to see a lot of that because again, they're not decomposing their work appropriately. And so we're tracking features that are completed and not completed and stories that are completed and not completed. And right now we're starting to see a lot of slippage, 17 months in, but velocities have stabilized, and you'll see that in the next chart here. So this is the feature velocities for all 6 teams. And this is PI 0 through PI 5, so 6 program increments. PI 0 is not represented here because the contractor elected not to track features and stories for the first program increment because they brought in so many new people. They wanted some time to ramp up again. So you're only going to see 5 PI results. The first one is the systems engineering enabler group. Pretty steady up front. Now they're starting to dip a little bit in terms of their velocities, but we're not too worried about that because there's some early low-hanging fruit stuff that they got done, and now they're actually working on some pretty difficult system engineering features, but they've never had any spillover into other PIs, so they're in pretty good shape. Second one is the software factory. Started off strong, and then they had the velocity dropped drastically, and this happened for 2 reasons. Okay? First reason, despite that 15-month study to look at modernizing the software factory, a decision was made at the last minute to change the direction that they want to take the modernization. So that created some conflict and confusion amongst the team members. So productivity slipped somewhat. And second, we had 10 members of a sprint team that represented the software factory during that 15-month study. As soon as we got into the Project D, that grew to 30 people. Okay. Communication breakdown. So they started to get a handle on that. As you can see, we're starting to build back up. So no longer do we have 1 software factory team, we have 3 to try to minimize that communication challenge. The other 4 are the actual mission teams. Still early to see what they're going to settle down into, but you can see generally, at least with missions 1, 3, and 4, they're getting much more efficient as they're moving along. Mission 2, we'll see where that goes, but so far not too concerned about it. One thing I will note, though, that this is the total number of features completed per increment. And except for the little dip there, and again, I will attribute that to the software factory issue, pretty consistent. They're getting around 80, 81 features completed after every PI. So despite some of the variability within each team, the overall project is showing roughly a consistent velocity. And currently we're at the very tail end. Actually, we finished it yesterday. PI 6 finished yesterday, and it came out to be 81 features. So they have found their sweet spot in terms of a collective team. Now, that doesn't mean there's a lot of slippage. Okay. So in this chart, ignore the first column, PI 0. That's an artifact that I didn't get out of here. But PI 1 through PI 5, these are the features that didn't complete within the program increment. In other words, they slipped over. Again, you're going to see some of that in any Agile program. You just don't want to see a lot of it. Okay. And it looked like things were in the right trajectory, but now they're growing. And PI6, it's even higher than this. So we got a lot of slippage going over. Yet that previous slide, velocity is pretty consistent, 80, 81 features per PI. So what's happening is some of these features are slipping, and I'll talk about why in a minute, but the team is pulling work off the project backlog and bringing it in and completing those, which is what you want. That's a healthy Agile program. So far, things are pretty good, but we are starting to see a lot more slippage and a lot more pulling forward work that was supposed to get done in the future is now being worked on now, which actually has another set of problems, which we'll talk about at the very end. Oh, and the very far column, those are actual features that spilled over and didn't get worked. They're still sitting on the project backlog. They're not overtaken by events. They have to be finished. Some of that's because priorities changed, and some of it's because of blockage issues, which we'll get into in a minute. This is another look at the same issue, except instead of features, we're looking at stories. Okay, and you can notice the trend line is starting to grow, that we're starting to see more and more stories slipping from sprint to sprint. Interestingly, what's in red here, ignore the two greens because they seem to have, excuse me, got back on track, but then we're back to the same problem. The red, that's the number of stories that slipped on sprint number one of that increment. Then they sort of caught up. Then sprint number one of this next increment, they had a spike in the number of stories that spilled over. Why? Okay. Two reasons. One is the stories that didn't get completed in the last PI automatically get assigned to the first sprint in the next PI, and they already have a full stack. So there's no way they're going to get it all done. Okay. Right. Two, there's pressure on these contracts to get things done. All right. And so they are anxious after that 1 week off, kind of taking it easy, have a cup of coffee. They pile a lot of work on that first sprint because they know they've got to get done. The clock's ticking. And so they take on way more work than they should ever have allocated. We keep telling them not to do that, but it's human nature. We want to try to get ahead of the curve. That's what's happening right here. All right. And in this one here, it's just, again, a number of stories that are spilling over, but in this case, they're not even being worked. They're just sitting on the backlog. And you notice the trend is going up. So we are starting to see some pressure on this project. So some reasons for that spillage, blockage, lack of resources. Probably the biggest challenge we have right now is we need a near operational environment for doing integration and testing. Okay. We can't test on the actual satellites. They're not even launched yet, but we need a constellation in order to test the command and control system. So you need simulators. Well, we have some, but they're not completed. They've been delayed, and that has caused a lot of the features to get pushed to the right into the future PIs. Big problem. Big problem. There's also software licensing issues and things like that I'll talk about in a minute. Competition for staff. This is reality, right? There's no program that I know of that doesn't have challenges with staff. Either they quit and go to another company, or they transition to another project, or they're borrowed temporarily to work on another project. That's not going to change, but we're going to have to find a better way of managing that in terms of allowing a sufficient margin inside those PIs. Underestimating code complexity, okay, another big challenge. Some of this is natural, it's discovery, because it is agile. So you don't have a complete system design when you start coding. There's a lot of unknowns, but most of it is attributed to a lack of understanding of the system requirements. And they don't understand a lot of this. In fact, some of the team that come on have never worked on satellite systems before, or even command and control systems. We have a problem here with this. And then, of course, changing priorities of features and stories. You know, we get a lot of RFCs, requests for changes. It's new, higher priority tech insertion that has to come in. That's going to naturally push features out into the future. Not much you can do about that. That's just part of the process. So, finishing up, observations and recommendations based on what we've learned so far. Okay. One is you want to do some upfront engineering, good upfront engineering before you start actually developing the system. I'm not talking about the old waterfall way where you did everything and you kind of designed down to the nuts and bolts and then have to change it, right? Not talking about that. Talking about black boxes. You know, what is this black box supposed to do? Not how it's done, but what's it supposed to do and what are the interfaces? Without doing that, you're not going to have a good project backlog to start with. And you're definitely not going to understand the dependencies. So if you do need to move features around, who are you going to impact? Remember, these are multiple teams and each have their own little project backlogs. Okay. And again, goes to helping the team better understand what the requirements are of the program. So they're not surprised when they get to the black box and they already have an idea of what it is. And they may even actually have an idea of how to do it, but it's not a surprise. And we have to do a better job of this. A lot of people think Agile, I don't need to do any system engineering. I just start. You can't do that. You just can't. Again, need an near operational environment up front. This is really for that horizontal integration and testing. When I talk about horizontal, I'm talking about the whole constellation, everything, all the external interfaces, because you can have vertical integration and testing where you're just sort of testing a subset of the overall enterprise. You can get by, but signing off on requirements, the government's not going to sign off on a requirement unless it passes the horizontal integration and testing. I would argue that a statement of work to a contractor, the very first deliverable should be a near operational environment for integration and testing. Because without it, you can't do integration and testing. And then you just keep pushing features off. Allocate stories to sprints at the beginning of the program increment. Okay. A lot of course books I've read will say, it's stories you have, allocate to this first sprint. And as you start working this first sprint, you start figuring out what stories to put in the second sprint. It's not working. Okay. You got to allocate them out because of the problem of people coming and going on your project. You need to have an idea of what types of skills you're going to need down the road in that program increment and plan accordingly. And you want to know what the complexities of those stories are. You want some hard ones up front, but not all the hard ones up front. You want to space them out. So you need to really think about in that 13 weeks, what are you going to do? Because it goes fast. Yeah, plan margin, this is like, Agile 101, but it's so often forgotten. If you have the capacity to do 60 story points in a sprint, allocate enough work to do 45 because you're going to need those extra 15. It happens, okay? But it's forgotten. And that's where the government needs to step in and say, look, trim off some of that work. Focus on the MVPs and MMPs when you're doing program increment planning, okay? This is really important because in the current project that I'm working with our team, we have an MVP that's not due until 2024. It has all kinds of features assigned to it. So why should I be worrying about that now? Well, there are so many features currently assigned to that. If I don't start working them now, I will never get them done in time. So I need to know what's coming up down the road. Challenges with implementing Agile in a hybrid environment. And this is what we're going to be working on next, is how to get past this. We're working Agile and we're using Jira, for example, to track the daily progress of the project, that's almost always out of sync with the integrated master schedule. And that's a problem because the integrated master schedule is where all the charge codes are. This is what the contractor gets paid by. Okay. If they're out of sync, you got a problem. They're way behind on charge codes. And the team is moving ahead of where they should be in terms of, so it messes up the EVM. Second, EVMs and IMSs have these things called work packages and planning packages. So if you have a PI and you got a planning package that's 2 years out, but you want to pull that feature forward to work on it, that's an overhead cost. There's a baseline change because they got to change accounting numbers and et cetera. So it just complicates the problem. That's a work in progress. I don't have a solution yet, or we don't have a solution yet. Get licensing, IP issues, accreditation, like on your simulators, done up front. Don't wait. Don't wait. If you have to go through an IP, it could take a year to get IP issues. And again, that pushes your features off in the distance. A couple more, and we're almost there. Need for onboard and continuous training. You need packages that bring on novices. You need packages, training packages to, your agile experts, because things change all the time. And don't forget to have training on the domain you're working in. So if you're doing command and control for space vehicles, training on space vehicle operations is essential because you're hiring people, a lot of them from industry. Google, they don't do anything, at least my team doesn't do anything with space vehicles. Okay. And finally, be prepared to customize your performance tracking tools. Okay. The contractor has theirs, the government has theirs. Hopefully they're the same, but not always. And even the contractor and the government may want to collect certain metrics, but they can't. And the reasons are multiple. Okay. One is that there are software incompatibilities. You may have a software tool that's by vendor A that provides you with what you want, but it doesn't interface with the version of Jira that you're running. Okay. This is huge. Okay. This is a huge issue. Okay. Foreign ownership of tools. There are a lot of nifty, agile DevSecOps tools, even digital engineering, model-based system engineering tools out there. Unfortunately, we can't use them on this project because of foreign ownership issues. Okay. Big issue. Okay. And if you do find something and you bring it in, it has to be screened, right? For security purposes. That can be monthly, several months, half a year long process. So one of the things we've done is and finally, access challenges. The government, military personnel have laptops that pretty restrictive in terms of what types of VPNs they support and that kind of types of tunneling you can do to get into Jira, for example, or Confluence. While university, we're NIST compliant, but we have a little more flexibility. That's a problem. So what we've done is we have an ability to export most of the data that the contractor is collecting, not most, all of their data. And now we've using Microsoft Excel, very powerful tool with Visual Basic. We've customized and built tools to give us up to the minute vision, a picture of what's going on. So, and that's a future paper we're going to write about those tools. So be prepared to write and develop your own performance tools. So next steps, definitely getting down to the wire. Continue working what we learned from Project C and from the initial phases of Project D, and I keep applying them. Obviously, keep collecting metrics, but the big issues, that third bullet, we need to really work on how to deal with this disparity between the old waterfall methods of accounting and project metrics versus the new agile DevSecOps world, where things are much more fluid. And that's the big challenge we're going to work on in the next future. And then the last bullet before I close up is we are also looking to join some other projects because the more projects, the more data we have, the better I think we're going to have in terms of what are the lessons learned that can be applied to other parts of the DoD enterprise. So with that, thank you. Questions? Greg.
Right, first, really nice data there. The one thing I'd like to ask is, because of software engineering person here, you had the features and the user stories, and you talked about the slippage there. Is there any attempt to look in to do a semantic analysis of the features and the user stories to see, was it certain aspects like communications or something like that that were showing you there? Because all features aren't equal.
That's right.
All user stories aren't.
Right. So that's okay. Partially, we've done a study on that. Okay. A lot of those early wins were because they were really just, even the software teams, the mission teams, they were doing systems engineering work. They weren't doing actual coding. Okay. And so that's subjective as to, did you complete the task or not?
Right.
While coding,
Yeah.
it works or it doesn't. Okay. When you do a unit test, it's either working or it's not, or if it's not working, you report a bug, right? Okay. And it goes on the pile. But complexity of the features, that we're just now starting to get a handle on that and starting to monitor that, because we're now getting into the really details of the program, and those stories and features are very complicated. And that's, again, coming back to this idea that part of that is the team really doesn't understand the requirements.
Yeah.
So that's one challenge. Yeah. Yeah.
Brief domain
Yeah.
knowledge.
Yep.
For each user story or each
Yeah.
feature is something that you have to
Right.
rate in some way.
Right.
Because 81 is good, but there's slippage.
Yeah, things moving. We can only move stuff from the future onto after a while we run out of tarmac. That's right. Yeah. Very good question. Yeah. Yes, in the back.
There's been simulation experiments that have questioned whether the benefits of agile that are seen in software engineering can be seen in system engineering, mainly due to the inability to silo the problem like you had in software engineering, where system engineering is a lot more couplings than the disciplines in subsystems. What are your thoughts on that?
That's a very good question and observation, and I agree that agile in systems engineering is a lot more harder to deal with than it is in software. Not to say that it's trivial in software, it's not. But the systems engineering aspect of this, which in NCOSY, they're focusing a lot on this right now. Excuse me. And the way around that, I still believe, although this is just, we need to do more research on this, is to do a much better job of upfront engineering, to understand what those dependencies are, not to do a full system design, but to at least get the black boxes drawn out as to what has to happen here and who's going to do it, not necessarily how it's going to be done. That's a detail that can get ironed out. But that's yes, agile and systems engineering. There's some papers coming out from NCOSY here in the near future that are going to try to address that issue. Yeah, good question. Yeah. Other questions? Yes.
Part of that effort.
Yes, I am. Yeah, a small part. Yeah.
So, usual suspects, right?
Yes, like Rick Dove and others. Yes, yeah. Okay, you know who I'm talking about. Yep. All right. Thank you.